Alright, well, welcome back to another beautiful Algebra 2 lesson. So today's lesson is going to be about dividing polynomials, but I want to review a little bit about multiplying polynomials before we start. So in our do now here, we're talking about multiplying polynomials in order to kind of set up the stage for talking about the opposite of dividing. So we have here a rectangular kitchen has a length of 9 meters and a width of 5 meters. What is the perimeter of the kitchen and what is the area of the kitchen? So this first problem is just kind of to get you to think about how we think about finding a perimeter of a rectangle and an area of a rectangle in the context of a real world scenario. So in this case we have an actual kitchen. So you want to draw out a rectangle and label your length of 9 meters and your width of 5 meters, and then figure out the perimeter of that. So I actually want to take a break from the PowerPoint to go over that. So just give me a moment for my hover cam to load. Okay, here we go. So I have here in the screen, let me turn off this. Okay, so I drew out a little rectangle. So this is our rectangular kitchen space, and we have a length of 9 and a width of 5. So perimeter, just in case you don't recall, to find the perimeter, we add up the length plus the width plus the second length plus the second width. So we add all these things up to get the perimeter. So that would be 9 plus 5 plus 9 plus 5. And then we just do some simple arithmetic to add this together. 9 plus 9 is 18. Plus 5, 19, 20, 21, and 2, 23. Plus another 5, 24, and 5, and 6, 27, 28. So our perimeter would be 28. And more specifically, our units here, if we go back to the PowerPoint, are meters. So this is 28 meters. Okay. Then our second problem from the PowerPoint was a rectangular rug this time. Oh, sorry, I skipped the area. Let me go back. Don't forget the area. Okay, area, on the other hand, for a rectangle is the length times the width. These are both important formulas to remember for ACT, SAT, other math classes, and so on. So area is the length times the width, so that's 9 times 5 here, which is 45. And this is square meters, because we have 9 meters times 5 meters. These m's we treat like variables, so this is m squared. So 45 square meters, or 45 m squared. Okay, so that's our answer for this one. We can also write this one just for consistency, 28 meters for the perimeter, 45 meters for the area. All right, this second problem is where the polynomial multiplication comes into effect. So feel free to pause it for a second to see if you can work through what the perimeter and area for this particular problem is. So I'm going to continue assuming you've paused it and tried to figure this out on your own, or you haven't paused it. So our rectangular rug has a length of 3x plus 4 meters, and it has a width of 5x squared plus 6x meters. So we want to find the perimeter and the area. So what is the perimeter of the rug in simplest forms? So the same way we did this first problem over here, we're going to do the second problem. So we're just going to add up two of the widths and two of the lengths for this particular problem. So that means I'm going to do 3x plus 4. I'm going to use parentheses so that I don't mix up the different terms. Plus 5x squared plus 6x plus another 3x plus 4 plus another 5x squared plus 6x. Okay. Now that we're adding these like, we can only add like terms here. So I'm going to circle and underline like terms. So my first term has an x, so let me just start with that. So I have 3x, I can add 6x, I can add this 3x over here, and I can add this 6x here. I can't add these to that because this has an exponent of 2 and this one doesn't. So 3 plus 3 plus 6 plus 6, that's 18x. Alright, what else? I have a 5x squared and a 5x squared. I can add those to get 10x squared. And then lastly, I have a 4 and a 4. I can add that to get 8. And then lastly, it's common practice that you start with the largest exponent and end any polynomial with the constant. So I'm just going to rearrange the terms, put the 10x squared first, then the 18x, and then the 8. And this will be my final answer. Of course, don't forget your units, meters. Alright, let's move on to area. So here's our polynomial multiplication. Area equals length times the width. So that means we're going to take 3x plus 4 and multiply times 5x squared plus 6x. Another way we can write that is without the multiplication symbol. Anytime you see two parentheses next to each other like this with no symbol in between, it implies that we're multiplying. That's what it means. So we're going to multiply, so we need to distribute. The 3x gets multiplied by the 5x squared and the 6x. So that's 3x times 5x squared plus, don't forget your plus sign. Don't just write the terms randomly. A plus sign is going to go between these terms. Then 3x times 6x. Okay. Then the second term here is 4. 4 gets multiplied by 5x squared and 4 gets multiplied by 6x. So plus 4 times 6x plus 4 times 5x squared. Actually, for consistency, let me change this around a little bit. Let me put the first term first. 4 times 5x squared plus 4 times 6x. Alright, so multiplying, remember that you multiply the coefficient, so 3 times 5 is 15. Add the exponent, there's the imaginary 1 here, so x cubed. Plus, bring down the plus sign. 6 times 3 is 18. X stays the same. 1 and 1 is 2. Bring down the plus sign. 4 times 5 is 20. X squared, bring that down. And then plus 6 times 4 is 24. Bring down the x. I hope my sound is recording because that will be bad if it wasn't. Okay. Now we have only 2 like terms here. Everything else we would just bring straight down. 18 plus 20 here. Okay, so here we've switched. We're now adding these these terms. That's why we're no longer multiplying the coefficient, adding the exponent. We're now adding, so we just add the coefficients, 38, and then keep the x squared. and then bring down the 24x. Again, this is meters squared. That is our final answer. Alright, going back to the PowerPoint. So that was just a do now to help us kind of work through it. And I gave you that information here as well. I included it in the PowerPoint. I just wanted to go through that with you. Alright, so today we're going to talk about division, polynomial division. Some important vocabulary here is quotient, the result or answer to dividing two polynomials. So when we divide two polynomials and we get an answer, we call that answer the quotient. Remainder. Remainder is the portion of a polynomial that cannot be evenly divided. So if we were, for example, if we were to divide 17 by 8, you're going to get a decimal. Using like real numbers, you'll get a decimal. So we call that having a remainder. With polynomials, it's the same idea, except it won't necessarily be a decimal. It'll be some number or variable that doesn't evenly go into another polynomial. Numerator is the top of a fraction. Denominator is the bottom of a fraction. Occasionally, when we're dividing polynomials, fractions become a part of it. That's why I wanted to include those two definitions. And then next, there's two ways that you can see polynomial division within this particular lesson. There's division term by term that you're going to see on Khan Academy. That's the first example he does. And you divide the coefficients, subtract the exponents. So think of it as the opposite of multiplying. With multiplying, you multiply the coefficients and add the exponents. So division is like the opposite, so to speak. And then long division. Long division, on the other hand, we divide the polynomials like regular numbers. So there are 4 steps, and the steps are a little convoluted in terms of the wording. But basically, the order is we divide, we multiply, we subtract, and then we bring down. So I give you an example here. This is another case where you may want to write the division alone. Try to work it out on your own and then come back to the problem. So for this particular problem, I'm showing all the steps at once so that you understand how to go about dividing. Dividing polynomials. So we always start with dividing. So I'm going to do the problem on my whiteboard here on my screen. And I am going to go through it quickly. But remember, this is a video, so you can always stop it, pause it, and rewind if I'm moving too fast through the problem. So I'm just going to write it out. Let me share my screen. Okay, so here is the division problem that I'm giving you to begin with, that I'm showing in the PowerPoint. So here, what you see is you have a x cubed term, x squared term. You don't have an x term, but you have a number constant here. So what I did first was just rewrote this so that I'm seeing all the terms. So this is what we would consider kind of like an advanced polynomial division problem. So what happens is I use 0 for the missing term because I want to be able to say I have every term from largest exponent to constant. A cubed term, a square term, or a single exponent of 1, and then a constant. So then I'm going to start the division process.